In this video, we are going to make a SG3525 based brick control module. This module can be used for making the inverters and DC-DC converters. So here I have made the PCB of this module, and this module have a low battery protection and the overheating protection. So here I am assembling all the components on the PCB and properly solder them. And here after soldering completed, the PCB look like from the back side, and the IC which is SG3525 and LM358 for controlling the temperature and low battery protection. So this is the 10 kilo ohm NTC thermistor, and this is the 100 kilo ohm potentiometer for frequency controlling. So here on the multimeter we can see the voltage 13 volt. So the module is powered with variable power supply and it's 13 volt. So here on the oscilloscope you can see the frequency changing. By adjusting the frequency potentiometer, we can adjust the frequency up to 113 kilohertz, and the minimum we can be up to 30 hertz. So here I have used 3-pin jumper for selecting the high frequency and low frequency adjustment. So in this mode here you can see the high frequency is generating above 100 kilohertz. So I am regulating below 20 kilohertz or 30 kilohertz. So this is working very well, and the frequency is can be adjusting any point as we required for inverter and switching appliance like DC-DC converter. So here now I'm testing the low battery cutoff voltage protection. So I have set the cutoff voltage at 11.5 volt. So when the voltage goes below this, so the output PWM controller is turns off, and this is done by the BD140 PNP transistor which is on the PCB. And when the voltage rises at upper limit, so we have to press the reset switch on the PCB to activate the output PWM. And also this have a overheating protection, which is you can see when I heat the thermistor, so the output PWM becomes 0. And also you can see this have a soft start, which means output is slowly increasing. As you can see, the waveform is increasing slowly in the starting point. So this is the very useful in the inverters and also the DC-DC converters. So here in this mode here I am testing the output duty cycle controlling. So for which I am connecting the feedback wires to the PWM output and ground reference, so that we can control the output duty cycle. And you can see I am controlling the output duty cycle, and you can see the maximum duty cycle is 50%, and now it's increasing below, and also the waveform is showing properly. So this is the very useful for any kind of converters. And also this is the first video of this converter. In the next upcoming video I'm making a inverter or a DC-DC converter, and also with the load testing and regulation of this controller. So this is the today's video, and all circuit and PC files are also given in the description. So if you like this video, please like and subscribe to my channel and share with friends. So thanks for watching, and I'll see you in the next video.